Okay. So, let me show you what's on canvas already. I'm going to do a few problems today. And if you go to modules, week 1, this is what's already there. Your first homework assignment is posted. And the due date is September 4th, which is week from today, for 10 points. And whatever I'm going to, it says lecture 1, really today's lecture 1. Monday was just. So it has a file in there. Basically, whatever I'm going to do today is there. Kind of like, looks like a textbook, hopefully. It'll take a while for it to load or something. An error, but it's there. Here we go. Here we go. So we'll be doing this today. Fun. So it's already on Canvas. Homework 1 is there. And again, if you just go to modules, you'll get everything you need. I'll be posting solutions here as well. Or you can click on assignments, and the homework 1 is also there. Okay? So, does that make sense? And where is happy class? What? Oh, okay.
It doesn't make any sense.
That's not funny. Oh, I don't know. Maybe they're just gonna try to watch the recording. So, welcome. Okay. So what we're gonna do today, we're gonna talk about, because we're starting algebra, right? Algebra. And I think I told you that on Monday. As far as I'm concerned, you haven't had algebra. But you had arithmetic, meaning if I put whatever on the board with numbers and a bunch of plus or minuses, products and divisions, you're going to have no problem doing that. Adding, subtracting, multiplying. You think so? All right, we're about to find out. You're going to have, I have a nice little worksheet for you to find out what kind of addition and subtraction and multiplication and division you should be able to do. Especially adding fractions and those things. Those seem to be a little complex. So we're going to talk about expressions, both numerical and algebraic. Now, numerical expressions, you got a bunch of numbers. Okay, and you're trying to add, subtract, multiply, divide them using the 4 basic operations of arithmetic. Okay, addition, subtraction, multiplication, division. Of course, numerical expression, if I just write stuff with numbers, is first of all supposed to have meaning behind it. If I write something like this, 1/2 divided by 3, that's good. That's a numerical expression. It makes sense. You understand what you're being asked to do. But if I write something like this, 5 plus, and then I stop, and that probably has no sense. Makes no sense. So the second one, not necessarily a numerical expression. It has to be a complete sentence. We're kind of talking grammar right now. We have to express our mathematical feelings in a correct grammatical way. Okay? So I'm just going to start with a really big example. So example 1. Evaluate the following. What do I say here? Numerical expression. So it is parenthesis 2.73 plus 4.81 plus 3.27 minus 2.81 close parenthesis, all divided by open parenthesis 2/5 minus 14/15, all divided by, not done yet, 25 times 37 times 0.4. And of course, no calculus. Okay? So let's talk about this. It'll take us a while, and that's all right. I'm trying to prove a point here that, well, you see. So you are aware of order of operation. You understand how to compute it in which order. Well, tell me what do you want to do first? And there's probably no wrong answer to that question. By order of operation, what do we do first? Yeah, let's do the parentheses, right? Yeah, so I have to look at this first big thing, and I need to figure out what that is, right? Then what do I do? Let's say, okay, I did that, I added them together. What do I do next? Yeah, the second parenthesis, I'm going to do some fraction stuff there. And then I'm probably going to perform the division, right? I do parenthesis, parenthesis, then I'll divide. Figure that? And in order to divide fractions, I have to multiply by the reciprocal. And at some point, I will have to figure out what the denominator is and divide. Is that fun? All right, well, let's think about this. So the first thing I'm going to do, I will have to compute, as you told me. I'm going to break it down in pieces. I'm going to try and compute this. Okay? It's not fun, but it can be. Remember I was talking about brute force method. You can just kind of thrust yourself through this problem and just get an answer. So we actually literally have to add 2.73 to 4.81. Can you tell me what that is?
7.54.
Very good. 7.54. Good. And then I'll have to add this two, right? So 7.54 plus 3.27. 8.81. And then 10.81 minus 2.81. Well, that looks awfully lucky. 8. Now, this is the brute force method where we just went in a row and we just added those numbers. That was kind of, well, I mean, we're all capable of doing that, but it's a little ugly. But real numbers have certain properties. I can rearrange numbers around the plus sign. One number plus another number, same thing as if I flip it. So I can probably notice that, are there two numbers that are easy to add together? Easier than just going in a row? What do you think? Yeah, it looks like it should be pretty easy to do 4.81 minus 2.81 together. What about 2.73 and 3.27? Is 7.3 going to play nice with 2.7? Yeah, so maybe I can rearrange them. Maybe I can say, well, this is 2.73 plus 3.27 first. Just do that first. And then do the other two. 4.81 minus 2.81. Right? Because if I do that, 2 plus 3 is 5. 0.73 plus 0.27 is just 1. So I get what? 6. And this difference, 8 one's just going to go away, then 4 minus 2 is 2. Right? So that's 8. Be careful, there's this wire. Lucky things.
I thought you were so excited about it.
Oh, I don't know what to do. But anyways, brute force, mathematical, what's the word? Well, trick or treat, I don't know. It's nasty. Finesse, I don't know. That's what you're going to be trying to do in this class. You want to try to find those shorter, prettier cuts. And we used few properties of real numbers. We used the so-called commutative property, that you can rearrange things around the plus. Remember those terms, commutative properties? We use the so-called associative property. If you have several numbers in a row adding, it doesn't matter how you pair them. That's called associative property. I'll write them all down eventually. But we use those two major properties of real numbers, commutative and associative. We need those properties in order to solve equations. That's what we do. You cannot solve equations if things don't commute. Yeah, commuting is important. All right. Well, let's look at that second parenthesis. So that's 2/5, is it? 2/5 minus 14/15. And I know we reviewed that on Monday, I think, right? We did common denominators. You realize in order to subtract fractions, you need to find the least common denominator, which is what in this case? 15. Well, we agree that LCD is 15 in this case, which means the first fraction is happy, while the second fraction is missing something. What is it missing? 3. Very good. So I need to multiply the second fraction by 3/3 to get 15 in the denominator, and I'm multiplying the numerator as well. So that's 6, what? 15 minus 14, 15. Right? What is that going to give us? What? Negative 8/15. You hear that? So now look at our numerator. Our numerator is 8 divided by negative 8/15. Something is going on there, right? So let's try that. So the third step is actually getting the big numerator. Which right now is 8 divided by negative 8/15. At this point. Did you hear that? Because we can do the first parenthesis, that was 8. We can do the second parenthesis. Question? So how do we divide by negative 8/15?
Turn it into a fraction.
Oh, it's already a fraction. Well, turn 8 into a fraction. Yeah, okay, good. So I'm going to write 8/1, and then what? Multiply by the reciprocal, so times negative 15/8. And we have to remember to do what first before we multiply fractions? What we should do first? Yeah, reduce. So 8's are gone. Right? Do that, because it's really redundant if you multiply 15 by 8 and then you divide by 8 at the same time. So let's just cancel them. So what is left? Negative 15. So that big ugly numerator, that big ugly thing on the top, yeah, you did live. So, sorry. So the big numerator collapsed into negative 15. Isn't that cute? Look at that. That big thing. Happy. All right. So that's our numerator. Now let's get denominator out of the way. Let's get denominator out of the way, because that one is not friendly. What is the denominator? 37 times 25. And I said 25, right? I didn't say 25?
Yeah.
And I wrote 24?
Yeah.
Yeah, I do that. I do that a lot. 25, because I'm already thinking about 0.4 over there. Oh, actually, I wrote it wrong. It's 25 times 37 times 0.4. That's the original. Sorry. Does it make a difference when I wrote 37 times 25 times 0.4? Not really. Because again, real numbers commute over products, right? Now this is awful. How do we compute that? So we can do 25 times 37. Whatever that is. What is that? Yeah, or what was that? Yeah, and you'll get the answer of 370. Is that the answer? 330? No, I think it's 370. How'd you get that?
Same stuff.
Same stuff. You want 25 times 37
And that answer
times 0.4? No, that's not right. I mean, your steps are right. You made a mistake somewhere.
270.
370? That sounds right. Now, did I multiply 37 by 25 in my head and then multiply by 0.4? The answer is no. Is there a way to pair those numbers? There are two numbers that are easy to multiply. What? 5? What is 5? I see 25. And I see something that is close to 4, don't I? What is 25 times 4? 100, right? It's 4 quarters. It's above, right? 25 times 4. But what is that 0.4 is doing? It's dividing by 10, really, right? It's taking away a 0. So if 25 times 4 is 100, what is 25 times 0.4? 10. So if I just pair these two numbers, 25 times 0.4, that's 10. Do you see how that's 10? It's 25 times 100, move a 0. Move 0 back. Okay? Well, then this whole problem becomes 37 times 10. And that's 370. So that makes it a whole lot easier. What?
Sure does.
Another way to look at this, and I'm going to start my campaign of convincing you that fractions are basically your best friends. Now, you're not buying that one yet. Well, let me show you. 25 times 0.4 is still hard to comprehend. I mean, it's easy if you think of this 25 times 4 and take away 0. But if you're actually going to start multiplying with decimals, it's a little nasty. But 0.4 as a decimal, can you rewrite it as a fraction? As something over something? You can always write it as 4 over 10, right? 0.4 is 4 over 10. And that reduces to 2 over 5, right? 4/10, both multiples of 2. And then you can reduce 5 and 25. You can always reduce your fractions. So you're left with 5 times 2, that's 2. So if 0.4 was written as 2/5, it would be a much easier problem rather than 25 times 0.4. So fractions are good because you can reduce them. That's the big thing about fractions. Okay, good. So 370. So the whole problem now is negative 15 divided by 370, right? Oh, that's already something. We can reduce that. It's clear that both numerators and denominator are divisible by 5. Is that right? They both share 5. So I can reduce by 5. So the numerator becomes negative 3. And what about the denominator? That one is, I don't know how to do it the easy way, but you just have to kind of force your way through that one. 74? What do you think?
Am I allowed to have a calculator right now?
Yeah. We're not there yet. You don't need a calculator for that. 74? Okay. So that is the answer to that big, nasty problem. The way you get 74, the way how my mind did that, I knew that the closest number that I can easily divide by 5 was 350. Because I know 35 by 5 is 7, so 350 by 5 is 7. Okay? So I just divided 350. How far away am I from 370? How far away 350 from 370? What is 20. So what is 20 divided by 5? 4. So I got 70 and I got a 4, so I got 74. That makes sense? Yeah. I'm not trying to do what that guy was doing by no means on Monday. But we're getting there. We're trying to do those computations because we're looking for shortcuts. the way I was doing 370 divided by 5, I did 350 divided by 5 plus 20 divided by 5. Because I can do 350 by 5, that's 70. Because 35 by 5 is 7. And I can do 20 by 5, that's 4. So that's 70. Okay. Does that make sense? All right, good. So I have a whole thing of notes on that one. Okay, so let's see. We reviewed. So what did we review? This one problem helped us to remember commutative associative property for addition, commutative associative property for multiplication, and it helped us to review how to add fractions or subtract, which is the same thing, how to divide, multiply fractions, and how to reduce fractions. One problem. I like that problem. It's good. So, properties of real numbers. So, commutative for addition. Basically, all it says, A plus B equals B plus A. And we use that today. Where A and B are any two real numbers. Okay? A, B, and C are any real numbers. You'll see C shortly. Associative property. Which is, if you have a sum of, let's say, three things, A plus B plus A plus B plus C, it doesn't matter in which order you add. You can add the first two and then add a C, or you can add the last two and then add an A. So that doesn't. That's the associative property for addition. We also have commutative property for multiplication. And then just AB equals BA. And of course, that's and we'll have associative property for multiplication. Is that okay? And that's, again, very similar to the one above. If you have a product of three numbers, then it doesn't matter in which order you parenthesize them. That's the verb I just made up. Isn't that fun? Well, let's try to verbalize this. Because we're also going to try to distinguish between our regular spoken word and a mathematical word. Because in math, to state the commutative property is really easy. A plus B equals B plus A. Makes sense? We see that? Good. But try to say this in just language, without saying A plus B equals B plus A, because that's just, you're just speaking math. But just so you know. where's my piece of paper? It took me a while to verbalize it. And this is fun. You know how to say this in English? You're not gonna like it. But in English it stays switching the order of addends. That's what a part of the sum are called. Does not, did I spell it right? Yeah. Does not affect the sum. So this is the same simple statement, A plus B equals B plus A, in plain English. This is hard. Actually, it took me a while to recover the words addends, because you don't hear them very often. You hear words factors, right? Switching the order of factors doesn't affect the product. How would I? Okay, I think that's the only one I had strength to verbalize, and I just gave up on that one. Because how do you verbalize parentheses? I mean, we understand what parentheses are mathematically, but what do they do? So I guess the order in which you group the addends in the triple sum, well, triple, that's the mathematical term already. And the sum, okay, I give up. So anyways, math is good for you. You know, it just makes those long sentences very short and condensed, and they make sense. Now, okay. So anyways, you're going to have a little worksheet where you're going to practice with your numerical expressions. And the purpose of that worksheet is just to make you miserable and hopefully cry. And that's the worksheet one. It's awful, and so sorry about that. I apologize in advance. The rest of them are going to be better. But this one is just to kind of set the tone. Anyways, algebraic expressions. So when we talk about algebraic expressions, we introduce letters, and we call those letters variables. Okay? So an example of an algebraic expression is, let's say, a squared minus 36. Okay? Now there's nothing much I can do with that expression when just written like that. A squared minus 36. I can ask you to factor that expression, a squared minus 36. Can you break it down into the products of things? And we'll be able to do it later. I can ask you to evaluate that expression if I give you the value for the variable. I can ask you, evaluate the expression when, let's say, a equals 10. Okay, so I'm just giving value for a, and you're going to say, well, it is, if a equals 10, then I'll get 10 squared minus 36. And I can compute that, right? What is 10 squared? 100, so this is 100 minus 36, which is 60, okay? So here we go. So I can give you any value for a. I can ask you when a equals negative 3, for example. So a equals negative 3, that means what? What do I write? Like that? What does that equal? What's 9? So here, this is why I was doing that. So let's start a debate. The way this is written, because both of you are actually correct right now, it is 9, but the way it is written, it is negative. Okay? Because when it's written like that, negative 3 squared, all it tells me is square 3, negative sign just kind of tags along. Negative sign is not being affected by the square. In order for you to square negative 3, it has to say that. Okay? So this is negative 3 squared. Right? Because when I see a negative 3 squared, this is the same thing as negative 1 times 3 squared. That's what that notation means. And now the order operation tells me, well, do the exponent, so that's 3 squared, that's 9, but then there's that negative 1, so that's negative. Okay, so there's a big difference between negative 3 squared, that's 9, but negative 3 squared, that's negative. Okay? Now in our problem, it was asking to square a, whatever a equals to. So since a was negative 3, I have to square the entire negative 3. So negative sign becomes a part of the square. And believe me, this is a very common confusion among all students, no matter where you at. Oh, I want to catch you early. So those parentheses do matter. But yes, it is. That gives you 9. Negative 36 stays the same. And 9 minus 36 is negative? What is it? Right? Okay. Let me give you another algebraic expression. Doesn't have to have one variable. It can have 2 variables, 7 variables, whatever variables you like. Okay? So if I try this example, here's an algebraic expression. A squared plus 2ab plus b squared over the product a plus b, a minus b. Again, later in your math courses, you'll be asked to, simplify this thing, reduce that fraction, whatever. And we'll be able to do this later in this semester. But for now, I'm just going to ask you, can we evaluate that given the values for a and b? And here's my first question. A equals 1, b equals 2. So can we evaluate that when a equals 1 and b equals 2? So for every a, I'm going to put a 1. For every b, I'm going to put a 2. So I'm going to write it like that. 1 squared plus 2 times 1 times 2 plus 2 squared all over 1 plus 2 times 1 minus 2. So for every a, I put a 1. For every b, I put a 2 in this case. Okay?
Yes, I'm just trying to remember the order of operations.
Oh, what is the order of operations? That's a good point. PEMDAS, right? What is P? Parentheses. And that's the one I never know how to spell. What is that one? Exponents. What's that one? Now, please make sure we understand that all those are separated by a comma. First parentheses, then exponents. But multiplication and division, it doesn't mean that you multiply first, divide second. You can do them, in any order. So that's and. But addition comes after division and multiplication. So addition and subtraction, there's no specific order between them. I don't know why I said m is m and d is d. M is multiply and d is divide, and then add and subtract. So that's the order of operations. Okay? So parentheses, exponents, multiplication, addition. Okay? And of course there's that silly thing you use to remember that. What is the silly thing? Yeah, that one. Could you say it to everyone can hear?
Please excuse my dear.
That's the one. Is Aunt Sally famous? Is that why? Or is this just because I don't know how that helps. You just have to remember a whole new sentence. If this was, Aunt Sally from a movie about Aunt Sally, that had to be excused. Anywho, let's compute that. So we do, in the numerator we have to do exponents. So 1 plus, in the middle we do the product. What is that? What's that? Well, 2 plus 2 times 2, 4. Plus 2 squared, 4. Over, we'll do parentheses. 1 plus 3, 1 plus 2, is 3. That's what I do because I already think 3 and I say 3. Well, it still says 2. So please forgive me. The other one is negative 1, right? So we'll continue with that. So numerator is 9, denominator is negative 3. Now it looks like we understand the denominator is division. It looks like I was adding the numerator before I was dividing. But remember that the way the fractions are written, there's a silent big parenthesis around the entire numerator, and there is a silent big parenthesis around the denominator. You have to compute those first before you do that big division, just in case. So negative 3. Right? Okay. Now if I change this a little bit, I'll scroll it up. I'll give different values for A and B. So A equals 3.7, B equals negative 1.7. That's going to be ugly. But, so if I plug it back into my algebraic expression, is 3.7 squared plus 2 times 3.7 times negative 1.7 2ab plus negative 1.7 squared. Please notice how I'm putting the parentheses around negative 1.7 because I want it to get squared entirely. All over 3.7 plus negative 1.7 and 3.7 minus negative 1.7. Now that numerator is just awful. I need to square 3.7, and of course if you're that guy from Monday then it's easy. But we're not, so we need to suffer through that. 3.7 squared plus 2.3.7. I'm just taking it separately. So how do you square 3.7? Well, it broke. Well, multiply by itself. So, or just 37 times 37, and then remember, keep track of 2 decimal places, right? So if we do that, is anyone already doing their long multiplication thing here? Getting ready for the big nasty worksheet? Is that right?
Yeah.
Okay. Now, how about the one in the middle? That's even worse, isn't it? that okay? If you actually do the math here, it comes out to be a pretty even 4. Because when you subtract these two, that's 1.11, and you add 1.11 to 2.89, that's 4. Okay, so the numerator is a pretty 4. There is a way to just know that it's a pretty 4 without doing the intermediate computations, and we'll see that later. Okay? Maybe I'll tell you. There is a formula that you will learn at the end of this semester. We'll focus on it a little more. That I'm going to do this in Magic Pen. So this expression in the numerator actually equals to that expression. A squared plus 2ab plus b squared equals to a plus b quantity squared. And if you try that, if you just add a and b, 3.7 plus negative 1.7, that's 2. And you square that, that's 4. Okay, the same. And of course, we'll learn all those sneaky little cuts. All right, but anyway, so the numerator came out to be 4, so that's good. Now the denominator, we need to do 3.7 plus negative 1.7. Well, that's simply 3.7 minus 1.7. Plus or minus just gives you a minus. So that's 2. Right? 3.7 minus 1.7, that's 2. While the second little parenthesis says 3.7 minus negative 1.7. So that's 3.7 plus 1.7. And what is that? 5.4. Is that right? And of course, we still have a product. We still multiply. So the entire denominator is 2 times 5.4, which is 10.8. So that's the denominator. The numerator is 4. The denominator is 10.8. Can you leave your answer like that when it's a fraction and a decimal somewhere in there at the same time? And the answer is? Oh, it's not one now. Oh, but my question was, can you leave your answer like that? Does that accept to have a fraction and then a decimal? No, it's either one or the other. How do you fix that? How do you move a decimal? What? Yeah, so if I move the space, how do I move the space? What moves the decimal? Yeah, multiply by 10. Well, if I multiply the denominator by 10, I need to multiply the numerator by 10. So I move this space in both cases. So it's 40 over 108. Okay, now it's a little better. At least it's 2 integers. Now I can still reduce that, can I? I can probably reduce this by at least I can reduce it by 4. It's 10 over 27. If I reduce both by 4, I don't think I can reduce any further. So it's 10 over 27. Is that okay? Okay. Let's try maybe an easier version of the same problem. If I look at A equals 4 and B equals negative 4. So almost, yes. No, let's make it easy. Let's make them both 4, sorry. Let's do 4 and 4. So then the numerator is 4 squared plus 2 times 4 times 4 plus 4 squared over 4 plus 4 times 4 minus 4. Do you notice something right away? Just by looking at, there are really three parts to that. The numerator and 2 parentheses in the denominator. Is there something funky going on? There's one of those things turning funky. What was one of them? Right. You notice that 4 minus 4 will produce 0, right? And so that means whatever's in front of it doesn't matter. Since we're multiplying anything by 0, it's still 0. So no matter what, this problem comes down to be blah over 0. Right? So what happens? You mentioned it earlier. Right. We cannot divide by 0. Division by 0 is undefined. So undefined. Okay? So actually, if we take any two same numbers, 3/5 and 3/5, it will give you 0 in the denominator. If I do 4 and a negative 4, it will give me still 0 in the denominator. Also give me 0 in the numerator, but that's irrelevant. As long as you get 0 in the denominator, the things are undefined. So when we get into algebraic expressions, a lot of time we ask you, can you determine the condition, the values of your variable for which the expression is defined? Meaning, it remains to be a real number. You put a real number in, you get a real number out. While here, we put 2 real numbers in and we got nothing out. So we call that collection of values, we call it domain. Domain of algebraic expression. These are all values of your variable that produce a real number in the end. Okay? So the domain say the domain of algebraic expression is a set of all real numbers that the variable is permitted to have. That's kind of a weird way to say that. Meaning your answer is still a real number. The value of the algebraic expression still remains real. So one big problem is with the division, because we know we cannot divide by 0. When we learn about square roots, it'll give us another big problem. We cannot take square roots of negative numbers. But for now, really the big thing for us is division. Let me do this again. 7 over x. So we have a variable in the denominator, so we have to be very careful. We don't want the denominator to turn into 0. So the question is, what values of x will give you 0 in the denominator? What x should be to get 0? There. 0, right? If x is 0, then you're in trouble. So the domain of this expression will be all real numbers but 0. Okay? So the domain except for 0. Actually, I never did the sign in thing. So when x equals 0, this expression does not make sense. Because you get 0 in the denominator. Okay? How about 4 plus x over 5 minus x? Can we figure out the domain of this expression? We don't want to get x, we don't want to get 0 in the denominator. So what number do we have to avoid? 5, right? As long as x is not 5, as long as x is not equal to 5, we're good. If x equals -4, we get 0 in the numerator, which is okay, because we'll get something else in the denominator. But as long as x is not equal to 5, we're good. Because when x equals 5, this expression makes no sense. Okay, good.